Good evening, guys. So let me introduce myself. My name is Debangan Goswami. Currently, I'm pursuing my bachelor's in technology from IIT Jammu. So I'm wondering, just out of curiosity, do any of you guys know what really progression and series means? So progression is basically ordered set of numbers which is following a specific rule assigned to them, and series is the sum of the terms of this progression. So we can create n number of progression, right? But in this session, we'll focus mainly on two types of progression: arithmetic progression and geometric progression. Let's start and dive into it by starting with arithmetic progression. So arithmetic progression, or short form is AP. So basically, it is a type of progression wherein the difference between the term of the progression and the previous term in that progression remains constant throughout the progression. So if the first term of the progression is A, second term would be A plus D, third term would be A plus 2D, and so on till the nth term. And the nth term, as you can see from the pattern, can be written as A plus n minus 1D. Right? So let's try to find the sum of the terms of this progression. So Sn can be written as A plus D plus A plus 2D, and so on till the nth term. Right, guys? Now, I'll teach you a trick here. To find the sum, what we'll do is we'll rewrite the sum again, but in the opposite order, starting from the last term till the first term. So Sn can be also rewritten as A plus n minus 1D plus A plus n minus 2D, right, up to A. Right? Now, you'll see a very nice pattern being followed here. If you see, we'll now add these terms like this. So we'll add n terms like this, and we'll obtain on the left hand side, we'll obtain 2Sn is equal to 2A plus n minus 1D. Again, 2A plus n minus 1D. Like this, the pattern will continue for n terms. So 2Sn can be rewritten as 2an plus n into n minus 1D. Right, guys? So Sn is obtained as an plus n into n minus 1D by 2. So finally, the form in which we are familiar with is Sn is n by 2, 2a plus n minus 1D, which is also n by 2 into first term plus last term of the progression. Right? Another type of progression is geometric progression. So in geometric progression, each term of the progression is obtained by multiplying the previous term of the progression with a non-zero constant. Right? So the first term is A, second term is AR, third term is AR square, up to AR to the power n minus 1. Again, the Tn, the last term here, would be AR to the power n minus 1. So now, let's try to find out the sum of this series. So, again, Sn can be written as A plus AR plus AR square, like this, right? Up to AR to the power n minus 1. Now, what we'll do is, we'll multiply both LHS and RHS by the common ratio. Here, R is defined as the common ratio. Right? So, we obtain R into Sn is equal to, and we'll provide a shift in the RHS. So, in this way, AR plus AR square, right? This will go on, right? We'll get here AR to the power n minus 1, and finally we'll get AR to the power n at the last. We have multiplied R in both sides, so the last term would be AR to the power n in this case. Now what we'll do is we'll subtract both the equations. So in the left hand side, we'll obtain 1 minus R Sn, right? And on the right hand side, we'll get A plus 0 plus 0. See, every term is 0 till the last term is AR to the power n minus AR to the power n. Right? So finally, we are obtaining, what is Sn here? if we take a common, 1 minus r to the power n upon 1 minus r. So here, this formula is only valid if r is not equal to 1, right? If r is equal to 1, then Sn would be simply a plus a or multiply adding n times, right? So na. So if r is equal to 1, then sum of terms would be na, right? So I'll try to give you a question regarding these two concepts, but it's a tricky question. Let's see if you can figure it out, guys. So let's figure out the sum of a series like 2, right, guys? So basically 2 plus 4 plus 8 plus 16 plus 32, right? So this is a very common GP we are getting, right? So simply what with the sum in this case, first term is 2, right? Formula is 1 minus, common ratio is 2 to the power n upon 1 minus 2, right? Basically 2 to the power n minus 1 into 2, right? Now let's dive into a new type of progression, which is the AGP progression, which is also called as arithmetic or geometric progression. So what happens in this type of series is that if you are provided with a series like 1 into 2, right, plus 2 into 2 square, plus 3 into 2 cube, see what is happening here in this series? The first term, right, the first part of every term is following an arithmetic progression, but the second part of every term is following a geometric progression. So how do we take care of this kind of series, right? So what we can do, we'll write S as like this, same concept. We'll multiply this equation by the common ratio on both sides and provide a shift. So what is the common ratio here? It is 2, right? So 2s is equal to, and we'll provide a shift again, right? So 1 into 2 square, right? Plus 2 into 2 cube, right? And here it is going on till the nth term. So nth term in this case, as you can clearly see, it would be n into 2 to the power n, right, guys? So here nth term would be simply n minus 1 2 to the power n. Perfect. And finally, we'll obtain the nth term after multiplying 2. So simply in that case, n into 2 to the power n plus 1. Okay. So now again, we'll subtract both the equations. So here we are obtaining minus s, right, is equal to 2 plus, see, 2 square plus 2 cube, right? Like this, the series is going on till n term, for n terms. And finally, this term is being subtracted from 0. So we're getting minus 2 to the power n plus 1, right? So now this is converted to a regular GP, guys, geometric progression, right? So minus s is, this is what you guys know clearly. So a is 2 here. Again, r to the power n minus 1 upon r minus 1. So 2 to the power n minus 1, right? And finally, minus n to the power 2n plus 1. So we get s as n to the power 2n plus 1 minus 2 to the power n plus 1 minus plus 2, right? So this is how we are obtaining. Finally, final answer is n minus 1 2 to the power n plus 1 plus 2. This is the final answer. You can recheck also, guys. So see, the first term is 2, right? It's coming right. The second term is 2 into 2 square. Second term is 2 into 2 square. It's coming right. And we are fine. So before finishing the lecture, guys, I would like to throw a bit of a challenge at you guys. This question actually came in the JEE Advanced 2023. So I'll just write the question, guys. So basically, in this question, we are being given that let there be a number 7557. This 5 is repeated for r times, and total number of digits in this number is r plus 2 digits, right, guys? Wherein the first and last digit is 7, and in between every digit is 5, right? So now basically we have to find, we are given that s is equal to 77 plus 757 plus 7557, like this, up to 7, and the 5 is being repeated 98 times, and then 7, right? So basically, in the question it is given, if S is equal to 755 up to 7, 99 times plus M by N, provided that M and N are natural numbers and they are both less than 3000. So this question actually arrived in the J Advanced 2023, guys. And shockingly, only 0.26% of the aspirants who attempted J Advanced solved this correctly. So it looks like a tough question, right, guys? But there's a simple trick involved in it, and you only require basic progression knowledge to do this. You don't require knowledge of any formula or anything or retention powers, just basic tricks and knowledge to solve this question. So I'll give you some time, guys, 5 seconds to figure it out, and then I'll write the solution. Right. So I hope you found some kind of pathway to break this problem. So the solution is what we have to find. First of all, what is S given the question? S is 77 plus 757 plus 7557, right? 755. This 5 is being repeated 90 times, right, guys? Right? Now, the trick to this question is multiplying 10 on both sides of the LHS and RHS. And why this is being done, you'll see in a bit. So what is 10s? If you multiply 10 on both sides, it would be, and we'll shift one term. This trick is almost applicable on every miscellaneous problem of progression. You have to shift one term. What will we get? 770, right, guys? Here we'll get 75. Sorry, 1 second. Sorry for the error. Yeah, 7570, like this, right? Here we'll be getting 755 97 times 70, right? And finally we will have the term, last term, 755 98 times 7 and then 0, right? So now we'll subtract both the equations. So what we'll get after subtracting both the equations? In this side we are getting minus 9s, right, guys, is equal to 77 minus, you'll see now, surprisingly, all the terms, these all terms, the difference is 13, right? So minus 13, right? Minus 13, minus 13. For how many times this minus 13 will be obtained? 98 times, right, guys? For 98 times, minus 13 is being obtained. And right, 90 times minus 13 is being obtained. And finally, we have the last term. Finally, of the last term, which is minus 75. 5 is repeated how much? How many times? 98 times, 7 and 0, right? So we are getting minus 9s is equal to minus 1197. So this part is minus 1197, and minus 75570. This is repeated 98 times. So now the same trick again. This term, if you see closely, can also be broken into two parts. It can be written as 755 90 times, 99 times, and a 13, right? So this part is basically, if you see, is broken down into two segments: 755 90 99 times and the 13. So now just the remaining part is left. So you can see that we are basically multiplying LHS and RHS by minus 1 on both sides. So 9s is coming, the 13 will come out. 1210 plus 755 799 times, right? So what is S, guys? S is 1210 plus 755 99 times divided by 9. So you can see M is 1210 by comparing, and N is 9. So our final answer is M plus N is 1219. Looked easy, right? But surprisingly, only 0.26% of aspirants did this correctly during the exam. So yeah, so the basic takeaway from this is you have to stick to your basics, right, guys? Your basics should be very strong. Your concepts should be strong. You don't, if your concepts are strong, you don't require to actually retain or mug up all the formulas or etc. in math specifically. So if your basics are very strong, you can score pretty high in JEE Advanced and other competitive exams as well. So with this, I hope that you liked my lecture and coverage on the topic of progression. Thank you, guys.